Hi guys, I wanted to introduce our new unit to you via video since I can't be there today. So for today's lesson, we're going to start exploring two-step equations. Now we've had a lot of experience with this last year because we did hands-on equations. So this isn't going to seem super unfamiliar to you, but we're using different tools in order to model these equations today. Now, what we've done in the last unit was dealing with expressions. Expressions are one section of a equation, so one half of an equation. Everything that we're doing in this unit is an equation, so it has an equal sign and something on the other side. Where when we deal with expressions, we're trying to simplify, make things pretty. With an equation, we're actually going to solve. So instead of it ending with 2x plus 2 and being done, we actually want an answer. We want x equals and then a number. So for this lesson, for today's lesson, we're working on gizmos. I did not print off a sheet for this one. I think if you just explore it enough, you're going to get more out of it than if you're trying to figure out what the worksheet is wanting you to do. For this lesson, you need to do 10 of these models. And I need you to record your equations and your answers and your evaluations of them on a piece of notebook paper. So let me walk through the first one with you. So as you'll see here, our equation that we're working with is 2x plus 2 equals 6. And we're solving for x. Now in hands-on equations, we had dice and we had pawns for our x's. In this model, we have these things that kind of look like petri dishes. These are our x's. And instead of cubes with a number value, we have these little unit counters. So instead of a dice that has a number 4 to represent 4, we would use 4 of these little counters. Okay? So we have our constants that don't change, or our unit counters, and then they call these x cups or just our x's. Okay? Down here at the bottom gives you directions. So as you are working through these, if you get stuck, read down here. It's going to tell you exactly what to do. These are values. So as you put things on this board, it will tell you exactly what you've modeled. So you're always going to make sure that this down here matches this side of your equation. Okay? So we'll look here. It says model each side of the equation using x cups and unit counters, and then click check when done. So we have two x's. Again, we don't know what our x value is, so we have two x cups. So we have two x's plus 2. We know what those two are. We're going to use our counters. 1, 2. So we have two x's and we have two counters. Two x's because we have two x's here. And then we have our equal sign and our equal sign. So once we hit our equal sign, then we move to the other side of the equation, just like we did in hands-on equations. Now we just have a value of 6. There's no x's, so I'm not going to use the counter or the k-cup. I'm just going to use these unit counters, and I need 6 of them. 2, 3, 4, 5, 6. Notice at the bottom this says 2x plus 2, 2x plus 2. This says 6, that says 6, so I am all set. I'm going to click check. Okay. You modeled the equation correctly. Now click unit counters to subtract them from both sides of the equation. Can you isolate the variable on one side? Click check when done. When we were in hands-on equations, we learned the substitution property of equality, and we'll talk about that later, but basically what it says is you can remove something off the scale as long as you remove it equally off of both sides. So remember my analogy with the scale and the M&Ms that my mom would hide. As long as you take the same amount from both sides, then the scale stays balanced. That's what we're going to do here. So we're going to subtract counters from both sides. When it says, can you isolate the variable on one side? Remember, the variable is what we don't know. So in this case, it's our x's. I want x's to be all by themselves on one side. That's our goal all the time. We want all of our x's on one side, all of our numbers on the other side. So right now, what's keeping these x's from being alone are these two counters. So if there are counters on this side and counters on this side, I'm just going to click on them and watch. It will automatically remove them from both sides. So if I take one from the left, it will take one from the right. If I take another from the left, it also took it from the right. Now I've isolated my variable. All my variables are alone over here. Okay, I'm going to click check. It says you've isolated your variables on one side. Now to find the value of x, drag an equal number of counters into each x cup. Be sure to use all the counters. Click check when done. Now remember, on hands-on equation, we would have two pawns, 1, 2, equals a number counter 4, and I would say, well, what does each pawn have to be? You're going to do the same idea here. In that case, you use division, 4 divided by 2. In this case, we're using division, 4 into 2 groups, and we get 2. Click check. Very good. Each x cup has 2 counters, so x equals 2. On paper, check your answer by substituting 2 in for x in the original equation, and then click New for a new problem. This is the last part of your work that has to be done. Let me show you an example of what I'm looking for. So here's our original problem. Please write down the original problem. 2x plus 2 equals 6. Then I went through the entire model and I ended up with x equals 2. What we learned in the last unit is called evaluating. We're substituting in this value of x in for this x right here. Remember, we use an x when we don't know something, but now we do know. So this was 2 times something I don't know, but now I know what it is. So down here, instead of 2 times x, I'm going to use 2 times 2. And then I'm going to drop down everything else in the equation. Plus 2 equals 6. All I'm doing is taking this original equation and substituting the value of x in for that x. Now I'm going to follow through with my order of operations. I have to do multiplication before addition. So 2 times 2 is 4. Drop down everything else. Plus 2 equals 6. And if you really wanted to get super fancy, you could do 6 equals 6. If you end up with something true like 6 equals 6, then you know you have the right answer. If you end up with something like 7 equals 6, then something got mixed up and you don't have the right answer. So for each of your 10 problems, I need to see these steps. The equation, what your x value is, you plugging in that value into the original equation, and then confirmation, your check, if you will, with hands-on equation. What did you get that you know you're correct? I need 10 of these on a piece of notebook paper. It's due at the end of class. Make sure your name is on your piece of notebook paper and turn it in before you leave. Again, when you're done with this one, you just click New. It will give you a new equation. You need to be working on your own because your equations are going to be different than your colleagues because they come up randomly. You guys have a good day. Stay focused and get your work done.